More generally, we can't do that. So one thing you can do that's a little more general is to ask, how many dimensions in effect can a string oscillate into? And that affects the density of states that the string carries. So how many different states of the system you can have. So if you have a string, it oscillates, and it has more states if it can oscillate in more dimensions, but you don't have to have a large space-time in order to ask the question of what is the density of states of a string.
But just to clarify, if you have a string that's just sort of in 2 dimensions, you can jiggle it and it'll wiggle that way. If you have 3 dimensions, it can wiggle in more ways.
In more ways.
4 dimensions, it goes out of what your awareness is. And
right.
so
the number of states actually grows like the exponential of the square root of the number of dimensions when there's a normal notion of dimensions.
I was going to tell you that,
yeah. So what you do is you define an effective dimension where you just ask, this is growing like e to the something, like exponential of something, and you define that something as the square root of the effective number of dimensions. And now that quantity can change, and as you go toward a singularity like what we're talking about, it can decrease, and I think that's what we were talking about.
And it decreases until what happens?
Well, the best way of describing it in words is that the masses of everything grow exponentially as you approach this point.
But that's not what you told me in your office. No, you told me that there's some state where all the dimensions go away themselves.
Well, that's what I'm saying. So as you go.
Oh, that was what you were saying. I'm sorry, I missed that.
No. Okay, let me try and close the gap. So I've said 2 things, I guess. One is that, in effect, the masses are growing exponentially, and then I've also said you can measure the effective dimension by asking about the density of states. So let me just say, as you go toward this phase where the masses are growing exponentially, that number, the effective dimensionality, is decreasing.
Until
0.
Until you don't even have dimensions.
Right.
Okay, so your flugelhorn theory here, that's in some dimensionality, isn't it?
Well,
it's embedded in something that presumably has a larger dimension than what it's embedded in.
It just has the number of dimensions it has, which I'm saying is 4,
Yeah, but it exists in a...
No, that's just to help you visualize it. Out there is nothing.
In string theory, you can, the string theory can predict many universes with all sorts of dimensions, and 4-dimensional universes might pop into existence, and 6-dimensional universes and 2-dimensional universes. We don't happen to live in those.
Okay, is there a highest number of dimensions that could possibly represent reality?
Well, it depends on the theory, I suppose. One might say 10.
That's a cop-out answer. I just want you to know.
Let me very quickly address that. You're about to say 10. 10 is a special dimension in string theory because it is the dimension in which you have what is called supersymmetry, extra symmetry. But it's in no way predicted by the theory. In fact, you can start, as you were just saying, in any number of dimensions. The difference between any other dimension than 10 and dimension 10 is that in any other dimension, there's potential energy from the start in your analysis. That's the only difference.
But the point about this is that the answer to the question is really, it's not, the interesting question is not why is there something rather than nothing. The amazing question would be why is there nothing rather than something, but we wouldn't be here to ask the question. If it was true. But the point is it would be amazing to have nothing. There's always going to be something. It's going to rise sometime, somewhere, and you happen to live where it is.
Charles, did people debate 0 when it was first introduced?
Yeah, it was a...
Who didn't like it?
Well, 0 was hated by the Greeks in particular because...
So they didn't have bank accounts that went to 0, like, like Jim's bank account.
They only had 0 for Jim's bank account when they borrowed from the Babylonians. They actually did... They did astronomical calculations in Greek numbers, and then when they realized they needed a 0 to make the calculations easier, they would swap into base 60 and use Babylonian 0 and the symbol for 0.
They did take from the Babylonians.
They took it from the Babylonians, but they didn't...
Base 60, so we owe our measurement of the clock time to them, which is essentially
correct.
Base 60.
That's
60
correct.
seconds in a minute, 60 minutes in an hour.
That's correct, and it was so repulsive to the Greeks that they refused to incorporate it into their own system. That it was basically a calculational tool that was used by the geeky astronomers, and we forget about it the rest of the time.
So is there some modern counterpart, because we're still human just as they were, and we have a philosophically informed gentleman here who just can't stand what's going on to his right. and they're grappling over some physical representation of nothing, and he's saying, whatever you've done, you still haven't given us nothing. So is this just the same argument moving forward?
I think in terms of, there's an aesthetic underlying fight here.
Because Lawrence loves his his universe from nothing. He's aesthetically turned on by that. I can feel it when I walk near him. Okay?
That's just personal attraction.
Yeah, I mean, there's all sorts of things that some of us, it takes time to change your aesthetics to accept. I mean, if you look
what
at
you're saying is some of the resistance was philosophically driven rather than practically driven.
Absolutely.
Okay.
Absolutely. If you look at the turn of the century, I mean...
no, we got to really specify which century you're talking about now.
the turn of the 1900.
Okay, thank you.
If you look at that time, that the atomic theory was relatively new, and modern atomic theory was relatively new, and there were physicists
Just to
who were out
clarify,
there...
the atom was still a controversial topic even in 1900, if I remember correctly.
Oh yeah, it wasn't accepted till after 1905.
Yeah.
There were big conferences on no
So
atoms.
Brownian motion, I guess.
Yeah, really, Einstein.
Einstein.
I think it was Ernst Mach who said, if atoms are true, I'm resigning, I'm giving up my position. Similarly...
and he was begging in the street, a few weeks later.
Exactly.
Okay.
He didn't believe in quantum mechanics either. Planck, essentially, even though he invented it.
And Einstein, even though he was one of the founders of
quantum
quantum mechanics,
well.
found it aesthetically repulsive. And some of his contributions, his best contributions, were trying to show that it was garbage.
But that's what's great about science. It takes what's aesthetically repulsive. It says the universe doesn't exist to please you. You may like it, but it doesn't matter. It may not be true.
Yeah, but
and if
Jim
it's true,
Holt
you got to learn to like it.
Jim Holt wants the universe to please him.
No, it's a crappy, mediocre universe. It's badly designed. No, I mean, the most interesting, the father of chaotic inflation, Andre Linde, told me that it would not be hard for a
Just
slightly
a departmental colleague of
yes,
of
that's
Eva
right, to
in
make a
Stanford.
universe in a lab. A hacker physicist in another universe could make a universe like ours in a lab with just 10 to the minus 9th grams of matter. And in fact, when you look at how imperfect and weird our universe is, it probably was made by a hacker. I mean, maybe there was a creator, but certainly not an omniscient.
Wait. You're saying
No, why are there 60 plus elementary particles? That is so inelegant. If I were designing a universe, it would be far more elegant than that.
It would have actually
And
have
why
nothing
is
in
that?
it, probably.
So
No, I mean,
why
a
four
universe that's
forces?
empty is
Why all
beautiful.
these? Why all this symmetry breaking?
No. In fact,
these-
people say one of the things that I really hate, and I debate recently in Sweden with theologians, is they say, well, they get this stuff that physicists talk about fine-tuning. They make it sound as if our universe is beautifully fine-tuned for life. It's actually could be much more beautiful and have life in it. And it turns out that there are lots of constants we don't understand, and they look unnatural. And maybe they are, and maybe it's fine-tuned, but it doesn't mean it's the best universe. But again, what's surprising about that? Bees can see the colors. It's cosmic natural selection. Bees can see the colors of flowers because they couldn't reproduce. If the constants in nature happen to allow us to exist, but that's not so surprising. What would be more surprising is they didn't, and we still did.
Rich, what's the famous quote from Alphonse X? Oh,
I think, there you go.
I thought you were going to say, is this the best of all possible worlds?
no, Alphonse. Nobody remembers this quote.
Is that
Alphonse X? No.
Why do you tell us?
No, that's Leibniz. Leibniz again.
Leibniz.
Is this
Okay.
the best of all possible
Alphonse
worlds?
X. Was it the 1300s? Something around there. He said, "Had I been around at the time of creation, I could have given some suggestions for God to have improved His work."
Okay.
Right. Upon looking at the actual vagaries of nature.
There's a lot of folks like that. Anyway,
Well, so Rich, I remember.
here's something nice. Here's something nice about the multiverse. I mean, what we know about the Big Bang is the Big Bang seems to be started by inflation. This is gravitational repulsion from the negative pressure that started the Big Bang explosion. And it seems to make multiple universes. Well, you saw 4 of them here. And there's no stopping it. And so it just keeps on making more and more universes. So, and I proposed the early model of this in 1982, a multiverse with all these different universes. And Linde has quite said, that, you know, the laws of physics in these different bubble universes or these different branch universes can be quite different. So now here's the
Different
nice...
in laws of physics.
Yeah.
Different
Well,
laws of physics.
not that
Martin
different.
Rees would say they're different. There's one
they're all low
laws
energy.
of physics, which is sort of string theory, let's say, and there's different bylaws here, and there's bylaws here, because the different vacuum states and the different multi-universes evoke different laws of physics. And so here's the nice thing. If you have a multiverse with an infinite number of universes here, some of them are nicer than others. Some of them are completely hostile and, you know, they're really hot and no intelligent life can live over there. And so luckily you don't live over there. and the universes that are more habitable, more people will live in. This is the anthropic principle. So some universes are populated by more intelligent beings. Some universes are populated by less intelligent beings. And so you're likely to live in one of the nice universes.
But, you know,
thank you.
Exactly. But, you know, our universe is actually pretty hostile. I always get amazed when people say
Yes,
our
completely
universe is
hostile.
friendly to life. Most of our universe is damn hostile.
Yeah, the universe wants to kill us at every opportunity
It's
it has.
amazing we've been here this long.
Remember that asteroid that just came?
I mean,
that's
it's amazing.
exactly.
There will be another one coming in the future. The universe is out to kill us and has been since we've been evolved. And
Jim.
And, you know, and in
But
fact,
still.
it's not so clear that, in fact, there are dangers of using the anthropic argument too, because it assumes typicality. I often say, if you use the anthropic argument for intelligent life, we should be having this discussion underwater.
Just to clarify, the
Three-quarters of the Earth is underwater.
of
No,
the surface of the
I
Earth.
would say-
Right. So wait. So the anthropic principle, just to put everyone on the same page, is the premise that you can marvel at whatever universe we're in, for whatever regions. Most of those occasions are theological, yet. But the anthropic argument would say, correct me if I mess this up. I think I have it right. So the universe that allows you to make that argument is the universe that allows you to exist to make that argument. And so there are people who want to then say the universe was made for us.
Well, the point is there are people who say, and we said it, physicists have said it for many different times over the last century. It's always been wrong, but maybe it's right this time. There's some quantities, like the energy of empty space, that seem so inexplicable from a fundamental physics perspective that people are saying, well, it is true that if it was much bigger than what it is, there'd be no galaxies. If there are galaxies, there'd be stars, no planets, no astronomers. So the universe is the way it is, so there are astronomers to measure it. And it sounds religious, but it's really, or tautological, but it's not. It could be true that it's kind of a cosmic natural selection. As I say, you just find yourself living in universes in which you can live. It's perfectly plausible. Where I take umbrage at it is some people who then make the claim that they can argue, they can understand why the fundamental constants are what they are, but that makes some presumptions about typicality, about us being typical life forms. And I don't happen to think we're typical life forms. We happen to exist pretty early on in the history of a universe that looks like it's going to exist a lot longer. And I suspect
trillions of years.
I suspect there'll be lots of life forms that are quite different from us in the future. So I don't think we're necessarily typical. We just happen to be here.
Jim, every
Well,
time you've opened your mouth, it has been in part to pass judgment on other people's offerings of a nothing. Do you actually have a nothing to put on the table other than arguments against other nothings that come before you?
No, I mean, first of all,
Okay.
I would say philosophers have talked a great deal of nonsense about nothing. And if you look at the philosophers who've addressed nothing in the history of philosophy, the earliest one was Parmenides, the Eleatic sage, and he said that we cannot speak of what is not. And in saying that, he violated his own precepts. So he got off to a very shaky start. Then we have Hegel saying
Wait,
that
the act of
that
saying
pure
you
being,
can't speak of what is not meant
Yeah.
he was speaking of what is not.
Exactly.
Okay.
Yes, exactly. Yeah.
Okay.
We can speak of what is not. I can speak, for example, I was going to make a very bad joke. Moving on to Hegel. Hegel said, what is pure being? Pure, indeterminate being. It has no qualities. It's the same thing as nothing. So Hegel said being equals nothingness, which is a great deal, very close to what you say. Also nonsense, but harmless nonsense.
Thank you.
Heidegger thought of nothing as an annihilating force that sucks things into existence and keeps them there, kind of like the vacuum cleaner in Yellow Submarine that sort of sucks up all the scenery and sucks up the Beatles, and it sucks up itself, and it nothings himself, and then the world pops back into existence.
The 60s was good to him. Yeah, okay.
And so, yeah, but analytic philosophers, serious philosophers in the tradition that I think is the greatest today, say, you know, that nothing is, it's a noun, so it seems like a name for an entity, but it's not. It just means not anything. There's nothing particularly mysterious about it. And so nothingness is a state in which there's not anything, period. Including fields in vacuum and so forth.
But there's no vacuum.
But then we should ask, why do we assume that the fact that there's a world rather than nothing requires an explanation? What's so special about nothing? And people say, well, nothing is the simplest. Does
everybody require that explanation that you've seen around the world? Because you said it requires it, but that could be a Western mandate that we've put upon ourselves.
The creation myth is always about how the world we live in came into existence. It may have evolved from an earlier chaotic state, or it may have been created out of nothingness by a god or something like that. There's only one, by the way, there's an Amazon tribe called the Pitaha, who I think is the only civilization known that doesn't have any creation myth at all. When they ask about the world, they say, it's always been like this.
Like Rich's thing. So Rich came from that tribe.
Physics would also always say, I mean, we're used to in quantum mechanics realizing that any possibility, anything that's possible, can exist.
Yeah.
And so the simplest answer is if a universe is possible, it has to exist. And it's not too surprising to find ourselves in it.
We're running low on time.
But there are lots of other possible universes that don't exist. So yes.
How do you know they don't exist? You sound like you've been there and looked for them and couldn't find them.
So that's interesting. You're positing a sort of a principle, it's traditionally called the principle of plenitude or fecundity, that every possibility is actual.
No,
there are universes that are ruled over by Greek gods and so forth. That's an interesting metaphysical idea.
That's not what I said. You said that other kinds of universes don't exist. I just don't know how you have access to that information.
No, I don't. It's possible that every possible universe governed by every imaginable combination of laws, and even completely lawless universes, it may all exist out there. Mm-hmm. So it's conceivable that every possibility is realized. I mean, this is an idea that goes back to Plato, and actually Steven Weinberg, who's the father of the standard model of particle physics, entertains this notion in his book, Dreams of a Final Theory, the principle of plenitude. It would explain why this world exists. This world is just one world in an ensemble of all possible worlds. And one of these possible worlds is the null world. It's nothingness. So in answer to the question, why is there something rather than nothing, you answer, well, there's not. There's both. So that's one way. I think that's a very extravagant metaphysical.
Very rare. I mean, the point is most of the worlds are not null. And that's why it's not too surprising to find yourself in not a null universe.
But why do we think that the null universe is the ontological default option? That's what's it is the simplest. It seems to be the least arbitrary. It's the cheapest because it doesn't cost anything. But actually, our universe is pretty cheap too. It has zero net energy. It's like Donald Trump, lots of assets and lots of
But we have zero energy. My point is, our
working.
universe has zero energy. It's no different than our universe. Our total energy of our universe is probably zero.
Yeah, so our universe is a cheap
emitter.
It's sort of a free lunch.
Likely to come from.
I want to go along the line here. We're running low on time. Plus, I want to make sure we have time for questions from the audience, from our Twitter stream, and from our overflow rooms. What's the best, cleanest expression of zero you know?
I think the mathematical expression where you start with zero and you remove it and you get the null set. That's my favorite. Nothing. Maybe that's the
But you start with zero and
you remove it and you get the null set. It's almost a platonic nothing, which is.
Wait, so there's a zero, which is nothing, but then you remove the zero and you have a set of things that doesn't even include nothing.
That's correct.
That's an awesome nothing.
It is the emptiness of all. There's nothing.
It's so empty it doesn't even have zero.
That's right.
Oh,
you can actually create zero out of the null set if you try.
You can create zero out of the null set.
There's a mathematical formalism that allows you to take the set of the null set and put it in a set, and that becomes zero.
Okay, I'm moving on right now. Okay. So Jim, your best nothing is what?
Not anything. That's the theory of nothingness. I'm sorry, it's no more interesting than that. And that's why, by the way, philosophers spend very little time vexing over the concept of nothingness. It's not that complicated.
So
Although hard to imagine. Once again, professional bullying on television.
Wait. So Jim, so you're saying all the philosophers who are still arguing nothing should just listen to you?
No, they don't spend. It's not a fruitful philosophical notion unless you make heavy weather of it the way Heidegger did and say it's this annihilating force that should inspire angst within our breast. I mean, that's kind of fun. Or to imagine, the world is a little sealed container of being surrounded, floating in a sea of nothingness, and a little bit of nothingness leaks in when we go into the cafe and we expect to see.
Did you
Pierre
use the word
there,
angst?
and Pierre. Yeah.
Okay. I just
it's the Upper West
caught up
Side.
with that
It's
sentence.
It's a philosophical term.
So nothingness induces angst in us.
Yes, in me it induces jollity. We all have different temperamental reactions to it.
Rich, you seem to be pretty cool with nothing.
Well, I'd say not there. What does it look like? What color is that? I mean,
Okay. So that's not even
there.
black. It's not even a
black. No, it's just not there.
So, Rich, is it fair for me? I don't want to stretch your analogy here because that was a good one. So, people ask, what happens to you when you die? You go to heaven or hell or wherever. And for me, the simplest explanation is your awareness is such as what you knew of the world before you were born.
Exactly.
Right? And so that's as nothing as you can possibly come up, other than Shirley MacLaine, who's been reborn many times. For the rest of us, that's like what's behind your head, right? Because you don't even see it. You don't even know to think it's there. So your consciousness before you were born, that's a pretty good nothing, isn't it?
Who knows?
Listen, we're all going to enter that state tonight, by the way, when we go to
I use
sleep.
this example because it's like right here.
Okay. What are you saying, Jim?
Dreamless sleep. We'll all enter that state tonight for a little while. We'll have a little period of nothingness tonight during our dreamless sleep. And
so there's no, that's
we don't have to think, what was going on before we were born. We dip into nothingness every night if we're lucky.
The absence of consciousness is probably the least satisfying.
Lawrence,
nothing.
what's your best nothing? You have a whole book on this.
Yeah.
By the way, all four of these gentlemen have books this evening offered for sale outside. We'll be at a table for signing. Eva has to actually leave for Europe tonight, so she won't be able to join us at the table. So, Lawrence, what is your best nothing?
Well,
is it the whole universe itself? Because I wore a vest for you tonight.
Yeah.
Okay.
Yeah.
I just want to say, I've got the entire universe on my vest, and
I knew it would come out sometime. I knew it.
You tell me all these stars, moons, planets, came from nothing.
Yep. Look, there are a variety of forms of nothing, and different one, and they all have physical definitions, and you might not like any of them, but one is empty space, the other is no space, and the other's no space, no time, no particles, no laws, and that to me is as close to nothing as you can get. And in fact, as I don't see why people have any problems with it. Each of these lights in this room emits a photon. The photon wasn't there before it was emitted. It wasn't in the electron. It wasn't in the atom. It was created from nothing. And some people don't have a problem with that.
No, it's created from energy. Created from energy. Lawrence, it was created from energy. And energy is not nothing. So I won't accept your photon.
Well,
analog.
it could. A zero
Back
energy,
up and say something
Sorry,
else.
a zero energy photon. A zero energy photon. Our universe could be like a zero energy photon, a zero energy total universe. And again, as I say, if you imagine that process and ask what the properties of such a universe would be, it would look like ours. But I will accede, as I've always said, and I say at the beginning of my book, that I will accede that the philosophers and theologians are, know much more because they are experts at nothing.
Not even universe.
So just Lawrence, just to close this out. So your universe that's created out of nothing, where there are no laws, no space, no time, no anything, that nothing had to know to create the universe.
Well, there may have been something else there, but our universe was
now
there.
you confess. I'm just trying to
Yeah,
understand,
there
because
was nothing.
if there's no laws, then there's nothing to know to create a universe.
What if there's every law? Is that the same as no laws? That's the point.
I bet.
Well, I think Jim was sort of saying.
I wasn't
Jim was
listening. What was
alluding that to every possible every possible law, every possible universe. There may be universes with no laws, there may be universes with laws. That's certainly a possibility.
All I'm saying is if you have a place, whatever that is.
There was no place.
If you have a no place with no laws, and then you birth a universe, something in that place had to know to birth that universe.
Why?
Okay.
Why, if it's possible, why do you have to? You're assuming intentionality. You're making this.
Eva,
You're purporting to offer us an
theology.
explanation, and you're offering us no explanation. All you're saying it just is.
Yeah, he's kind of doing it.
You're not talking about a process that's governed by laws, by rules, in which
we say
initial
what the
conditions.
rules are that caused our universe, but we don't ask, what happened before. Because
Do we have control over their microphones? Eva, give me your best argument for nothing.
I would just describe it as the absence of degrees of freedom. If you think about quantum field theory, again,
We do that all the time. Think about quantum field theory.
Yes. What you do with it is you think about it on longer and longer distance scales, and there's a precise sense in which as you do that, you lose degrees of freedom. And in a case of quantum field theories which have a gap between the ground state and the first excited energy level, as you course grain over longer and longer scales, eventually you come to a place where you've lost all the degrees of freedom. So the ground state of a gapped quantum system would be my answer.
The ground state of a gapped quantum system is your best nothing.
Yeah, I like that.
Okay. I kind of, my favorite nothing, not that anyone asked, but I will offer it because I'm host of the evening. My favorite nothing, I think, is what's outside of Rich's 4 universes. I kind of like that because you have no access to it. It's not even anything, and it's behind the head of each of those universes, and I'm kind of leaning towards that.
It doesn't even exist, which you may also like.
So let me offer just a final reflection on this. It seems to me that there was surely a time when nothing was just, I would say there's nothing between me and you. Then we learned that there's air, there's actual substance there, there's mass, there's energy, and so you couldn't call that nothing anymore. And then we learned that space has no air, and that's a relatively recent understanding. As late as the early 1600s, there were arguments that maybe you could fly to the moon, and by learned scientists. And the only way you could do that is if this air substance permeated the space between us and the moon. So now that when there's no air, so then space is the nothing, but then quantum physics, relativity tells us there's stuff going on even in empty space. So that removes that from our nothingness. And now we have to actually exit the universe, either sort of theoretically in the sense that Eva is suggesting, or outside because you created a model that we can look outside the universe. Now that's a nothing. And I just wonder whether this nothing is an all-elusive moving target, that one day we will learn that you do create those universes out of a law of physics. It's the universe birthing law. And then there's a law in the place where we previously thought there was nothing. And then that just simply pushes the definition of nothing that much farther away that you have to chase it down, because then the space that has the law that we previously thought was nothing that birthed the universe, you can then ask, what birthed that? So maybe nothing will never be resolved, and the only person who's content in his definition of nothing and it'll be permanent forever is Charles right here with his null set. Join me in thanking the panel for this. So we have 2 microphones up front. Feel free to line up. We'll spend 10 minutes, 15 minutes answering questions, then we call it a night. Okay, so we actually have questions in from Twitter. If you don't know what Twitter is, it's an extraordinary way to waste your time. Not quite as bad as Facebook, but it's up there. Okay, what are some of the practical, I'm going to take this to Lawrence. What are some of the this is from PsychMez1 on Twitter. What are some of the practical applications that can come from the discovery that nothing is unstable and creates particles? Is there any practical application for that?
Well, in quantum mechanics, there is the kind of, when one's talking about a universe, I should say proudly, there's no practical application I can think of to any of the work I do. And that's fine with me. In fact, it always amazes me.
Well, who pays your salary?
Well,
Is it fine with them?
No, but look,
I think that's the question.
Neil, but the point is, people never ask what's the practical significance of a Mozart symphony or a Picasso painting. It's part of what makes being human worth being human, and the ideas of science are among the most beautiful intellectual discoveries that humanity's ever come up with. It doesn't need anything practical. But in the idea that particles can spontaneously pop into existence is a very important practical aspect of all quantum mechanics. And in fact, in certain high fields and even in certain transistors and semiconductors, it's an integral part of modern technology.
So it does have practical application.
Yeah, of course, absolutely.
Okay.
But it doesn't need to be interesting.
Excellent. Next question, Capital Gambit, and this is from Twitter. What is more conceptually problematic? I'll take this to you, Charles. Nothing or infinity?
They're actually quite related. That infinity and nothing are almost two sides of the same coin.
So they have equal challenges to grasp.
That's right. That's right. If you think about,
except he has nothing in his bank account, and if he had an infinite amount of money, he wouldn't be complaining.
But the money would be worthless. So but a mathematical definition of the infinite is a set of stuff which you can take away from, and it's still the same size. And if you think about nothingness, you take away from it, it's still the same. So there's a lot of properties in common with nothing and infinity. In fact, part of the reason that nothing is so problematic is because when you're staring at nothing, you're looking down the face of infinity.
Wait. I thought if you take away from 0, you get negative numbers.
That's true.
But you just said you take away from 0, you still get 0.
Well, if you remove 0 from the set, you get the null set. But if you take away from 0, you get negative numbers, unless you're going in the opposite direction.
Right, but you didn't say that a moment ago. I'm just calling you out on that.
Yeah, you're right.
Okay, good. Okay, thank you. Right here, first question up.
I have to ask this because I'm a biologist, which means essentially an experimentalist. Is there any evidence of nothing?
There's evidence.
Wait, Eva, go.
Okay. So there's evidence of this inflationary theory that we keep talking about. The cosmic microwave background has a certain structure in it, in its fluctuations. So the so-called acoustic peaks in the power spectrum come about because of the initial conditions that inflation gives us.
But there's much. But as a biologist, you wouldn't be here. It turns out that the empty space that you may have learned in high school that protons are, if you're a good high school, protons are made of 3 quarks. We lied. They are made of 3 quarks, but in fact the quarks account for very little mass of the proton. Most of the mass of the proton comes from the fluctuations in empty space, in the nothingness of the proton. We can actually calculate it. And we get, in fact, a Nobel Prize was given recently for the theory that allows us to calculate that. So we know that these weird things are happening in empty space. And
This third nothing that isn't vacuum, isn't empty space. Is there any evidence of that?
Well,
of course there's vacuum, but is there nothing?
You mean no space?
Yeah. There's no experimental evidence of that.
No, absolutely, because we happen to live in space.
So if you put the experiment in the place where there's nothing, then the nothing is no longer nothing. It's got your experiment in it.
Yeah.
To measure the nothing. So then you can't ever measure nothing.
Well, that's there.
But that's the point. That's why it's not so surprising that there's something, because we couldn't ask the question if there was nothing.
All right. We'll get to this in a minute. Here, next one over here.
Oh, I'm a physicist and not a theologian, but since you guys and the lady began with a philosophical and theological, would anyone care to comment on at least my understanding of the Hebrew Bible, which begins Bereshit, which is the indefinite article in a beginning, not the beginning as it's translated into English. Anybody have any comments on that philosophy?
You started this, so let's go back over to you. So the question is, I don't read Hebrew, so I just trust what he says, that in the Hebrew Bible, it doesn't says, apparently it says in a beginning rather than the beginning.
Bereshit,
If you,
not Bereshit.
Well, I don't speak Hebrew myself, but in my studies, I've looked at commentary, and again, you're absolutely correct that some versions, and I didn't know that the Hebrew version said this as well, but it is indefinite as to whether there was a prior beginning. That in fact, it's much more explicit in the Greek version that in fact there might have been a prior existence and it had collapsed and there was a void. So, I mean, that's consistent.
But that's one of the reasons why it's so ridiculous to talk about theology when you're trying to explain the universe, because, you know, God speak Hebrew or Greek or Aramaic or Arabic. I mean, it's ridiculous.
Spoke English.
Doesn't explain anything.
Right.
I mean, they didn't even know the Earth orbited the sun, so why are we listening to them?
Next, right here.
My definition, my very basic definition of the universe was always everything. So the idea of a multiverse, and you're saying during a quantum fluctuation, a new universe is born. Why is that a new universe and not something that's part of the pre-existing universe? And
That's
what
Rich,
is a
why don't you take
universe
that,
if
Rich?
The multiverse is everything.
Well, the reason we use the
Just
word...
to clarify the question, he's saying if the universe is everything, why distinguish our universe from others that pop up in such a thing as the multiverse? Why even make that distinction? It's all the universe. Go.
Well, we use the word multiverse because these are expanding so fast that, as I said, event horizons arise between them. If you're in one of these funnels, light from the other funnel can never get to you. So we can never observe those other universes. So that's why we use that. That's why we use that word.
So universe is not everything; it's everything that you can interact with.
Or could have ever. The new definition of the universe is everything you could have once interacted with or you can ever interact with. So everything you can have physical contact with, either in the past or the future, is a universe. And everything that you can't have is not part of our universe. That's our modern definition.
Modern? How modern is that?
It's a good question.
But they all...
probably since we just thought of multiverse.
But these other universes are connected to us through the trunk of the tree. If you imagine it's a tree with many, many branches. We're on this branch over here. We can't see what happened on these other branches, but all of us have come from one trunk, which is the original inflating state.
But that's in that version. There could be other versions like string theory where there are literally universes that were never in causal contact.
Sure.
Okay.
If that can happen one place, it could happen another.
Next, right
It could
here,
happen
sir.
More than once.
Number one, thank you all for really making it, our minds expand with these things. But
Or implode.
Or implode. Either way, it's action of the brain, which is good. Do you ever feel that as long as we're locked within the confines of our human consciousness, that we're just fish trying to understand the land? And you up there remind me of flying fish that get a better view for a little longer than most. But are we really futilely listening to something about the Big Bang and the universe that may never really get there at all?
What he's saying is, how stupid do we think we are?
Well, look.
That's the question.
No, but
wait, Jim.
It's
Jim.
a really profound...
No, I got Jim.
Okay.
Pick that up.
Okay.
Did I characterize your question accurately?
You did. I
Okay.
mean, the thing is, it reminds me of a ar without positive traction with only one wheel spinning in the snow. Are we ever going to
We all
get
saw
all
that
four
movie. It
wheels
was a
and
good movie.
drive?
Yes. Okay, go.
State-of-the-art physics does not give us any satisfying picture of how the world is. According to state-of-the-art physics, there's this one thing called, a system, call it U for the universe, and it has a very complicated state, which is a point in an infinite dimensional Hilbert space, and the state that it's in is determined by Hamiltonian, and this is what reality is. It's not tables and chairs and rocks. And so when I see a bowl of cherries on the table, all I see is that the system U is in a certain region of the Hilbert space. That is the picture that physics gives us of reality. It's a terrible picture. I mean, quantum mechanics makes no sense.
You're agreeing that we're all too stupid.
And people say, just shut up and calculate. It works beautifully. So it's empirically adequate. It explains all the observational evidence, but it doesn't give us a satisfying picture of reality. So I think we talk very cavalierly about why there's something rather than nothing. We have the feeblest grasp of what something is and what existence is.
But, it's worse than that. It's empirically...
Wait,
No.
If it's worse than that, I don't need to know about it, okay?
No, empirically, we're limited by the fact that we happen to have evolved at 14 billion years, or roughly, into the history of the universe. There are questions we will never be able to answer because of the accident of our birth. And what's amazing is we're coming pretty close to some of them, and that's amazing. But we didn't have to, 20 years ago, 30 years ago, we weren't thinking some of these questions.
Wait.
Yeah, we're forever limited in our knowledge, and that's just life.
Lawrence, you're suggesting we're limited in knowledge because we're born at one time and not another time, rather than just that we're too stupid.
Well, it's a combination. We also
Okay.
may have limits in our brain.
I want you to admit that. Okay.
Yeah.
Sir, yes.
I was going to admit it for you, but I'm sorry.
Sir.
I simply want to follow up on the question that I asked earlier. Multi-universes, you're simply kicking the can down the road. Because at the end of that, you're going to ask it, nothing, and then there is another aspect of it because theological. Do you follow me?
No, I didn't follow it. Did you?
Let me reflect on it for a moment, okay? I've thought about this recently. The universe, we have come to learn with hard-earned science research, the universe doesn't make anything in ones, okay? We imagined that Earth was sort of unique among objects, and we found it was just one of a bunch of planets in orbit around a star that was pretty special to us. And then we learned it's just one of 100 billion stars in our galaxy. Well, the galaxy was special up until 1920. Then we had this debate about whether the galaxy is all there is or there's something else outside of it. We learned there are island galaxies out there, billions of them. And so then we have this universe. That's the one universe in which we're all contained. So maybe the universe doesn't even come in ones. And if that's the case, the multiverse picks this up, and then you have multiple universes. But that leaves me to ask the question, which we will not answer today, if nothing ever comes in ones, not even a universe, then would that possibly mean that the multiverse doesn't even come in ones?
Sure.
I don't know.
It's just... He said we're still kicking the can down the road, and I bet you Jim Holt would agree.
Whether there is nothing, or the other alternative is theological. It's God.
Well, there can be alternatives that are not always religious. That's an interesting false dichotomy that's often set up. If it's not this, it must be religious. No, if it's not this, it could be other stuff you haven't thought of yet. You can't assert an answer just because it's not something else. And it's a false argument that's been made throughout time. And the better scientists, as they move forward, never assume anything just because one thing is wrong. Yeah. Okay, right here, sir. We'll go another 5 minutes and we'll call it a night. Thank you. Yes.
Hi there. Good evening.
Good evening.
You guys mentioned quantum tunneling earlier, right? Which is
Isn't that cool, quantum tunneling?
Oh my God!
I would so want a quantum tunnel.
So I'm really glad that you're excited to talk about this. So you mentioned you can pretty much like go through a mountain without going up or around it, and a mountain being something. I read a couple of years ago that scientists were able to teleport electrons through a vacuum, like a distance of like nominal distance, like 9 meters or something like that, through a vacuum, which is pretty much nothing. It's the same thing that space is made out of. So is there really anything that's holding us back from with quantum tunneling and teleportation through vacuums, stopping us from taking things that are actual tangible objects and being able to teleport them? Is that something?
Okay,
something that's achievable?
Okay, I think we got to go to Lawrence on this because he wrote a book called The Physics of Star Trek.
Yeah, true.
Okay, all of it.
Yeah, no, I was going to say yes. So the answer, the answer is that it was really good public relations for people to call it quantum teleportation. And the answer is we can do strange things with electrons and photons, specifically because we can prepare them in very special quantum mechanical states. So we can do remarkable things with photons and electrons because we can prepare them in a very special quantum mechanical state and create these things called quantum correlations, which you don't need to go into, that allow you to do strange, miraculous, and crazy things.
At a distance.
But
simultaneously.
But we are not specially prepared quantum mechanical states. And therefore, we can teleport quantum mechanical states, but you and I have to take airplanes. Okay. I wish it wasn't the case.
Sir, right here, go.
I noticed throughout the talk that nobody seemed to strongly object to the idea of the degenerate state. Some people thought it might be a futile abstraction, and some thought it might be the possible point zero of our creation. At the same time, I noticed that the real arguments seem to be over the existence of spontaneity. Does anyone here have an aesthetic difficulty with absolute spontaneity? Not spontaneity that's just seems that way beyond our understanding of the universe.
Jim?
Absolute spontaneity sounds like something happening according to no law or no rule. Is that what you had in mind?
Yes, not dictated by external factors.
Yeah. Well, I mean, it's very problematic in what sense laws dictate events to begin with. I mean, if laws, you know, this is my complaint about Larry, is that he sees laws as though they're divine commands.
Who's Larry?
He doesn't like being called Larry.
Yeah.
So there's some needling going on here.
Professor Krauss. Laws somehow reach out to events from outside space-time and control the way events occur. They cause events to occur in a certain way, and that means, of course, if laws are causing events to occur, you need another set of laws to explain how the first set of laws cause events to occur. So it gets very messy, and laws are sort of like, you know, either they're like platonic, timeless entities that float above the space-time world, or they're like divine commands that exact obedience and prevent things from being spontaneous. I think that laws are simply high-level summaries of the patterns in the world, and that's why I don't see how you can appeal to laws to explain the existence of the world, to explain why there's something rather than nothing, because laws inhere within a world, they don't have any power to exact obedience from the world. The laws of Newtonian physics are a summary of irregularities such as the planets rotating around the sun. They don't force the planets to revolve around the sun in certain orbits. But I mean, I feel I'm evading your question about absolute spontaneity. Is there a world in which there were no patterns and no regularities at all? Is that conceptually possible? I think not, because there results in the mathematics of combinatorics, which say that there are always going to be some regularities. You can't have a completely random world. So, yeah, I don't think you could have complete spontaneity, but that sounds like I'm talking through my hat. No.
That's why I picked on you. Yeah. Next question here. We'll just take these last set of questions and we'll call it a night. Thank you, sir. Yes.
All right. So there is a theory that the universe runs on a cycle in which it ends and then, you know, everything shrinks back down to a really small size and the Big Bang happens again. The Big Bang is a reaction to something, and something has to trigger that reaction. And so does that mean that absolute nothingness can never, you know, exist? There always has been something?
So that's can I?
Yeah, Eva.
I mean, that's an interesting thing that should have been brought up. There's certainly a logical possibility of maybe an oscillating universe that never quite goes away.
It always was, if it's oscillating.
If so, I mean, there are models of this which work up to a certain point, but it's challenging. I mean, it requires a certain source of stress energy to obtain the sort of crunch bang that you're asking for repeatedly. And I don't know of a realistic model of that, but it's a perfectly good question to ask.
Thank you.
Yeah, it's not.
Your question got complimented, and we have no answer for you. That's what it sounded like. Okay.
They're models, but not good models. Yeah.
Typically, when a scientist says "good question," it means they don't know the answer, right? That's how that works. We'll go through these real quickly, sir.
So this evening seems to have been focused on defining nothing, definitions of nothing, but when it came to sort of the relevance of nothing, it was sort of quick to dismiss the question of why in favor of the question of how. And I guess to me it seems that the question of how is at least directionally simpler than the question of why, insofar as we may not exactly know the answer to how, but we keep getting closer as science advances us, and we really can sort of infer a first cause at least.
Is there a question?
Yeah, because
okay.
I mean, I think the point is how is a process, and if you go from the very first something and just go one step back to nothing, you no longer have the device of saying this caused this and this caused this and this caused this, because by definition there was nothing to cause something. So I guess my question is, you know, is the relevance, is our fascination with nothing in your views really coming back to the question of why. Why does this all exist?
Okay, so wait, just so Lawrence's book begins with the word why. Tell me the title of your book.
Actually, the title is A Universe from Nothing. The subtitle is Why Is There Something Rather Than Nothing?
The subtitle begins
why,
okay.
and then the preface I explain why that's a bad question.
Okay, but let me ask you.
But
isn't it true that we had an argument about the difference between how and why, and you were discarding the why?
Well, I don't think why has any meaning. Why assumes purpose. If you really mean why, always means how, unless you assume there's some intentionality. That's the assumption of why, and then you're assuming the answer before you ask the question. So why may not just be a good question. There may be no intentionality. There may be no reason for why the universe exists. There's a process of how it exists. And then the first cause, if time doesn't exist before the Big Bang, what do you mean by cause? What do you mean by before? Those questions, which have been so vital to the way people think, may just be bad questions.
Now, the question why does not, asking the question why does not presume intentionality.
What do you
I'll give you
mean
an example. Why, suppose we have the final theory, which everyone thinks is just over the horizon. Once we have that, as Steven Weinberg will tell you, or any reflective person will tell you, there still leaves open the question, why that theory? Well, one answer to that might be that it's the only logically consistent theory.
So
that's
the question
probably
really
not
is,
true
how did
because the
that
theory of
rise
nothing
out of-
is logically consistent. But so in a further answer, and this was sort of toyed with by John Archibald Wheeler, who coined the term black hole, among many other achievements, was Richard Feynman's teacher. He said that the laws of physics might be the only logically consistent set that permit the emergence of conscious observers. That would
But
be
I would say
another
that's a how
interesting
question.
why. Once
I
you've
think-
answered the how question, how the laws of physics ordained a universe, coming out of a patch of false vacuum, then you can further ask the why question about why the laws have this general form. And I think that that's not to be discarded lightly.
I would
That's an
say that's
interesting
a question
intellectual
of
inquiry as
how
well.
did the laws of
See what
physics
you started
arise in
here?
the form they do.
We got to move on. Okay. Thank you. Yes.
Well, Descartes' theory of I think, therefore I am kind of gives this idea of existence being something that we have to qualify. We have to qualify existence using some sort of description. And sort of, you were talking about how reaching behind your head in that space that we can't really see and can't really describe kind of gives a description to nothingness, but nothingness can't really be described. So how can we talk about nothingness when we can't really describe it?
You're a professor where? Yeah, I like that question.
Well, that's why I use the example, because you can't really describe what it looks like back there. So
Professor Gott's
metaphor
reference to nothing is the best answer to your question, because he didn't even describe it. He just gestured to it.
No, but look, physicists, the whole point of science is we actually say this we can describe and we can discuss it. And it may not be what you mean by nothing, but it's, so these are we try and make things well-defined, and inevitably they're mathematically well-defined. And that's the best we can do. And we can't do any better. And it may not satisfy you, but that's it.
Scientists try to answer the how question just because that's what the science can answer.
But you're leaving it a brute fact why the laws of physics take the form they do. And I think that the principle of sufficient reason, always look for an explanation. For any truth, try to find an explanation of why it's true. For anything that exists, try to find an explanation for its existence. This is a great principle that's always driven inquiry, and it's been the motor of science. And I think to discard it once you arrive at the final theory is a certain, it's intellectual philistinism, it's cowardice, it's laziness.
No, but I think it's just semantics.
See what you
I would
started?
say it's how.
Yeah, anyway. And you're all of those things, and a slut.
The last question of the evening. Sir, you better stop. Otherwise, I shut them up somehow.
I just want to thank you for being here. I was on my way to Acme Auto Parts, and somebody pulled me into the here. And I don't have the foggiest idea, but I just wanted to say my thought was that in the multi-dimensional universe, or the string theory idea, I wonder how many of these forums are going on out there in the universe right now, talking about the same things. The other thing is, if this is being recorded right now, I think at least what this panel and what this process shows is the passion with which we look at these things in science and trying to find the answers of how and why. And that's at least because if we record this and in 25 years we all come back and your son is the moderator tonight, and we look at everybody up here and what they've said, I wonder what they're going to be saying about, yeah, they were on target, you know?
I doubt it, really.
I hope we're all wrong. No, I really hope we're all wrong.
The other thing about Descartes, what I really understood was, and I have reason to understand that I'm pretty accurate in this, is that, because I was over in Paris a while back, is that his thing of je pense donc je suis, or I think therefore I am, was not the end of it. What we really don't know is I think therefore I am a something, and that was left out. So we don't really know what was after that. So.
Well, I certainly hope we're all wrong. I hope 25 years from now we've learned a lot more, and that's because we do science. And
right. So I think what I'm saying is that we don't really have the answers tonight. We have the best answers that we have at this point in time.
Excellent point to end this. But thank you all. I'd like to, just before we break, I just want to publicly thank some people who helped run this event. My executive assistant, Elizabeth Stachow, who runs my life. Laura Venner is our stage manager. Suzanne Morris runs the Hayden programs. And Dominic Davis is also active in making all this work. And a bevy of volunteers. I want to thank them publicly and give us one last round of applause for the panel. We'll see you next year or back at the tables where we have the book signing. You all drive safely. Thanks for coming.